pleasant morning to everyone, especially to you, Ma'am Jan. In this video, we will talking about cloud computing, open source software, and the open source developer. Imagine in a world where you can access all your data and applications from anywhere at any time without worrying about hardware limitations or security concerns. This is the promise of cloud computing, a technology that has transformed the way businesses operate and individuals interact with technology. What is cloud computing? Cloud computing is a method of delivering computing services over the internet. Cloud computing enables users to access data and applications anywhere in the world as long as they have an internet connection instead on relying on local servers or personal devices. Examples of cloud computing are Google Drive, Google Cloud Platform, and etc. The basic idea behind cloud computing is that resources such as storage, processing power, and software applications are provided as a service over the internet. This implies that users don't have to worry about managing physical hardware or infrastructure because they may scale their consumptions up or down based on their needs. Cloud computing offers numerous benefits to organizations of all sizes. One of the key advantages is flexibility and agility. Flexible because users can scale services to fit their needs, customize applications, and access cloud services from anywhere with an internet connection, making it easier to collaborate with colleagues and work remotely. Agility because cloud agility is the ability to quickly develop, test, and launch applications in a cloud-based environment. Much like in the athletic theater, agility makes it easier to move nimbly in response to changing environment or challenges. Next one is speed of deployment. In a cloud computing environment, new IT resources are only one click away, which means that you reduce the time to make those resources available to your developers from weeks to just a minute. Next is the cost control. By using cloud services, organizations can save money on hardware, maintenance, and upgrades as well as on energy cost. They provide access to a wide range of tools and applications without having to purchase and install them individually. Next one is scalability, which allows businesses to easily adjust their computing resources as needed. This means that they can quickly and easily scale up during periods of high demand or scale down during slower periods without having to invest in expensive hardware or in infrastructure. Next is robust security. The main objective of cloud computing security is to minimize the risk that organizations facing continuously and ensure business continuity even in the face of an attack. Encryption is one of the best ways to secure cloud computing system. Last is the freedom of location, means that a user can able to access the cloud service everywhere and responsibly regardless of his or her location.
So, next is the different types of cloud computing. The first one is Infrastructure as a Service or IaaS. So, it means a cloud computing infrastructure that provides compute, network, and storage resources over the internet via a subscription model that can scale. It also offers virtualized computing resources. Infrastructure as a service, organizations can rent and access infrastructure components such as virtual machines, storage, networks, and operating systems. For example of this is Amazon Web Services and Microsoft Azure and Google Cloud. Then, the second type of cloud computing is platform as a service. A cloud computing model where a third party provider delivers hardware and software tools to users over the internet. It also offers a platform for developing, deploying, and managing applications over the internet. It also enables non-developers to create web applications. So for example of this is Google App Engine and Windows Azure. And the last one is software as a service. It's a software distribution model in which a cloud provider hosts applications and makes them available to end users over the internet. It enables users typically pay a subscription fee to access the software, which is often based on a usage or licensing model. It involves the licensure of a software application to customers. Licenses are typically provided through a pay-as-you-go model or on demand. These types of system can be found in Microsoft Office 365. Then one of the example of this is the Google Apps. So how does cloud computing work? So cloud computing works by having companies host or maintain massive data centers that provide the security, storage capacity, and computing power to support cloud infrastructure. Hosted private cloud is one of the ways on how cloud computing works. So this model offers the same cloud of flexibility as the public cloud, but with the infrastructure needs, hosting data, storage provided by the companies or users of the services. Additionally, the restricted access and hands-on management of hosting gives the private model an extra layer of security. So another way of how cloud computing work is public cloud. This is the common and all of the players in cloud computing run public clouds accessible anywhere with login credentials and the right web app. Typically include conventional IT infrastructure elements such as virtual machines, applications, or storage. The last way is hybrid cloud. So hybrid cloud is a combination of the public and private models. The two cloud types are linked over the internet and can share resources when needed. So for example, if the private cloud reaches storage capacity or becomes corrupted, the public cloud can step in and save the day. Typically involves a connection from an on-premise data center to a public cloud.
Open source software is defined as a type of software that is released with a license granting users the freedom to access, modify, and distribute its source code freely. Open source software has become widely popular due to its numerous benefits. It often leads to reduced software costs as users are not required to pay for licenses. The ability to modify the software allows for customization, tailoring it to specific needs, or integrating it into existing systems. The transparent nature of the source code promotes security through peer review as vulnerabilities can be identified and addressed by the community. Open source software has fueled innovation across various domains, encouraging collaboration among developers worldwide. The vibrant communities that form around open source software, or projects rather, facilitate shared knowledge, peer review, and rapid bug fixes, resulting in robust and reliable software. By embracing the principles of openness, collaboration, and community involvement, open source software has revolutionized the way software is developed, shared, and utilized, empowering individuals, organizations, and industries alike. The history of open source software spans several decades and has its roots in the free software movement. In 1980, Richard Stallman founded the Free Software Foundation and initiated the free software movement. Stallman advocated for software that respects users' freedom, allowing them to run, study, modify, and distribute the software. In 1989, Stallman and the FSF released the GNU General Public License. This license defined the legal framework for distributing and modifying software while ensuring users' freedom. In late 1990, the term open source was coined to promote the pragmatic benefits of free software to businesses and organizations. The Open Source Initiative was formed in the 1998 to promote and advocate for open source software. The OSI established the open source definition, a set of criteria for software to be considered open source. In 2000 and beyond, open source software became increasingly mainstream. Major companies started adopting open source solutions, recognizing the cost savings, flexibility, and the security benefits. The key characteristics of open source software include access. Users have the right to access the source code of the software. This allows them to understand how the software functions and make improvements or modification as needed. The second characteristic of open source software is modification. Users are allowed to modify the source code according to their specific requirements. This flexibility enables customization and adaptation of the software to suit individual or organization needs. And lastly, one of the key characteristics of open source software is the distribution. Open source software can be freely distributed, meaning users can share the software with others either as it is or with modifications. This promotes widespread availability and encourages knowledge sharing. Open source software offers numerous benefits to individuals, organizations, and the wider software ecosystem. Here are some of their benefits. First is open source software is cost saving. Open source software is typically free to use, modify, and distribute. This eliminates the need for costly licensing fees, reducing software acquisitions and maintenance expenses. Organizations can allocate their budget towards other areas such as customization, support, or additional features. Another benefit of open source software is customization and flexibility. The access to source code allows users to modify and customize the software to suit their specific needs or preferences. Organizations can tailor open source software to integrate with existing systems, add new features, or remove unnecessary components, resulting in a highly adaptable solution. Another benefit of open source software is the transparency and security. The transparency of open source software source code enable users to review and verify its integrity and security. The community-driven nature of the open source software promotes rapid identification and resolution of vulnerabilities and bugs, leading to enhanced security and stability. Community and collaboration is also one of the benefits of open source software. Open source software fosters vibrant communities of developers and users who collaborate, share knowledge, and collectively improve the software. The community provides peer support, documentation, and user forums, creating a rich ecosystem of resources and expertise. Innovation and rapid evolution is also a benefit of open source software. Open source software encourages innovation by enabling developers worldwide to build upon existing projects and contribute new ideas. Developers can leverage or extend open source software solutions, accelerating the development and evolution of software in various domains. Vendor independence and longevity. Using open source software, it reduces dependence on specific vendors or proprietary solution. If a particular company or organization discontinues support for a proprietary software, the community can continue to maintain and enhance the open source alternative. Interoperability and standards. Open source software often adheres to open standards, facilitating interoperability and compatibility with other systems and tools. This promotes integration and avoids vendor lock-in, allowing organizations to choose the best combination of tools for their needs. Lastly, legal and licensing flexibility is also one of the benefits of open source software. Open source licenses provide legal frameworks that give users the freedom to use, modify, and distribute the software while ensuring compliance with the license terms. The variety of open source licenses allows organizations to choose the license that aligns with the requirements, risk tolerance, and business models. These benefits have contributed to the widespread adoption of open source software across various domains, including operating systems, web development, databases, artificial intelligence, and more. Open source software continues to drive innovation, collaboration, and cost-effective solutions in the digital era. Open source licenses are legal frameworks that defines the terms and conditions under which open source software can be used, modified, and distributed. These licenses ensures that the freedom and openness associated with the open source software are preserved and respected. The GNU General Public License is one of the open source licenses. It is one of the most well-known and widely used open source licenses. It ensures that any derivative works or modification based on the GPL licensed software must also be released under the GPL, making them freely available to the public. This copyleft nature ensures that the software remains open source and prevents it from being incorporated into proprietary software. Another open source license is the MIT license. It is a permissive open source license that allows users to use, modify, and distribute the software, including in proprietary projects. It places minimal restrictions, primarily requiring the inclusion of the original copyright notice and disclaimer in the distribution of the software. Another open source licenses is the Apache license. Apache license is another permissive open source license that permits users to use, modify, and distribute the software, including in commercial projects. It requires attribution of the original copyright notice and disclaimers, and any modification made to the software must be clearly indicated. BSD license are a family of permissive open source licenses that come in different variations, including the 2-clause or the simplified BSD license and 3-clause or the modified BSD license versions. BSD licenses allows users to use, modify, and distribute the software even in proprietary projects with relatively few restrictions. Lastly, Creative Commons licenses. While not exclusively for software, Creative Commons licenses provide a range of options for content licensing, including open source software. Creative Commons licenses offer a choice of permissions and restrictions, allowing creators to define how their work can be used, modified, and distributed. It is essential to carefully read and understand the specific terms and conditions of each license to ensure compliance with the chosen license and to avoid any legal issues. Different licenses have varying requirements and restrictions. So, developers and organizations should select a license that aligns with their objectives, business models, and desired level of openness. While open source software offers numerous benefits, it also presents some challenges that users and organizations may encounter. One is the user-friendly interfaces and documentation. Some open source projects may lack intuitive users interfaces or comprehensive documentation compared to their proprietary counterparts. Users may face a learning curve and requires additional effort to understand and utilize the software effectively. However, many open source projects actively work on improving user experience and documentation to address this challenge. Another challenges of open source software is support and accountability. Open source software is typically community driven, which means support and accountability may vary. Organizations using open source software may rely on community forums, mailing lists, or documentation for support rather than dedicated customer services. However, many popular open source projects have active communities providing support, and organizations can also for commercial support services provided by the third party vendors. Integration and compatibility is also one of the challenges of open source software. Integrating open source software into existing systems may pose challenges due to differences in standards, protocols, or dependencies. Compatibility issues may arise when combining different open source components or when integrating with proprietary software. However, the open nature of the software often allows for customization and community driven efforts to address integration challenges. Security and vulnerability management is also one of the challenges in open source software. While open source software benefits from community driven security reviews, vulnerabilities can still exist. Users must stay vigilant and apply updates and security patches promptly to mitigate risk. Organizations should actively monitor security advisories and maintain robust vulnerability management practices. Perception of risk is also one of the challenges of open source software. Some organizations may perceive open source software as riskier due to concerns about its stability, support, or legal implications. Proper due diligence, including understanding the license terms and evaluating the software maturity, can help address the concern. Fragmentation and forking. The open nature of the open source software can sometimes lead to fragmentation or forking, where different versions or variations of a project emerge. Forking can result in fragmentation of the community, divided efforts, and potential compatibility issues. However, forking can also be a way to foster innovation and address diverging goals or visions within the community. Lastly, lack of standardization is also one of the challenges of open source software. The absence of strict control in open source projects may result in different implementations and approaches to solving similar problems. This lack of standardization can sometimes make it challenging for users to choose the best fit solution or integrate different open source components seamlessly. Despite these challenges, the advantages and widespread adoption of open source software demonstrates its value and potential. Many challenges can be mitigated through community support, proper planning, and engagement with the open source ecosystem. The vibrant open source community continuously strives to improve the software, address challenges, and enhance user experience.
Next is open source developer. Open source developers or programmers are individuals who actively contribute to open source software projects, possesses technical skills and expertise in programming languages, software development methodologies, and version control systems. So naatay active contribution to open source projects, technical skills and expertise, software development methodologies, version control systems, collaboration and community engagement, continuous learning and adaptability, and passion for open source philosophy. Jakaning active contribution to open source projects, ang developers ani are not just passive users of open source software. They actively contribute to its development. They dedicate their time and skills to enhancing existing projects or creating new ones, collaborating with community of developers from around the world. So next is technical skills and expertise. Open source developers possesses a wide range of technical skills and expertise. They are proficient in programming languages relevant to their projects such as Python, JavaScript, C++, or Ruby. They have a deep understanding of software development principles, including object oriented programming, algorithms, data structures, and design patterns. Next is software development methodologies. Open source developers are familiar with various software development methodologies, such as Agile, Scrum, or Kanban. They understand how to manage projects, requirements, plan and prioritize tasks, and work effectively with a development team. Version control systems. Open source developers rely on version control systems like Git to manage their code base and collaborate with other developers. They understand concepts such as branches, commits, merging, and resolving conflicts. Version control systems allow them to track changes, facilitate collaboration, and maintain a well documented history of the project. Uh, Next is collaboration and community engagement. Open source development developers actively engage with the open source community. They participate in discussions, forums, and lists related to their projects. They provide feedback, share ideas, and help other developers with their questions and issues. Collaboration is a fundamental aspect of open source development, fostering knowledge sharing and collective problem solving. Continuous learning and adaptability. Open source developers have a growth mindset and a strong desire for continuous learning. They adapt to new technologies, frameworks, and tools as they evolve. They stay up to date with the latest trends and innovation in their field and continuously expand their skill set to meet the demands of their projects. And lastly, passion for open source philosophy. Open source developers are driven by a passion for the open source philosophy. They believe in the power of transparency, collaboration, and community driven development. They embrace the idea of freely sharing knowledge and software to empower others and contribute to the greater good. So, so there are rules of open source developer or programmer in open source software. So, mo ni sila ang mga rule. One is code development, bug fixing and issue resolution, featuring development and enhancement, performance optimization, security and vulnerability management, and collaborative and feedback, then documentation and user support. So, ang kaning code development, Usani si Joka, open source developers are responsible for writing and contributing code to the open source software project. They implement new features, functionalities, and module based on the project's roadmap and user requirements. They follow coding standards, best practices, and software design principles to ensure the code base is maintainable and scalable. Next is bugs fixing and issue resolution. Open source developers actively participate in identifying and resolving bugs and issues reported by users or discovered during testing. They analyze problem reports, debug the code, and propose fixes or workarounds. Their efforts contribute to enhancing the stability and reliability of the software. Next is feature development and enhancement. Open source developers collaborate with the community to identify new features and improvements for the software. They contribute to the design and implementation of these features, ensuring they align with the project's vision and meet users' needs. Their work adds value to the software and helps it evolve over time. Next is performance optimization. Open source developers focus on optimizing the performance of the software. They analyze and profile the code, identify bottlenecks, and propose optimizations to improve execution speed, memory usage, and overall efficiency. Their work contributions to making the software faster and more resource efficient. Security and vulnerability management. Open source developers prioritize the security of the software by actively identifying and addressing security vulnerabilities. They implement secure patches and updates. Their efforts ensure that the software remains secure and resilient to potential threats. Next is collaboration and feedback. Open source developers actively collaborate with other developers, users, and stakeholders within the open source community. They provide feedback, participate in discussions, and share ideas to improve the software. They contribute to the decision making process, providing valuable insights and perspective based on their technical expertise. So next is documentation and user support. So open source developers contribute to the documentation of the software, creating users guidelines or guides, API references, and technical documentation. They ensure that the documentation is clear, comprehensive, and up to date. They also provide user support by answering questions, addressing issues, and guiding users in effectively using the software. By fulfilling these rules, open source developers actively contribute to the growth, stability, and sustainability of open source software projects. They collaborate with the community, continuously improve the software, and ensure its usability, reliability, and security for users worldwide.